Okay, today we're going over geometric dilations. A dilation is when you are given an original figure and you are transforming it into a smaller or larger figure. This example is a polygon and it is represented with A, B, C, D, and E. Okay, you are going to use the scale factor of 1/4 to perform a dilation on this, and you are going to plot your coordinates, and for each coordinate you should have a prime symbol for the new coordinate. So to perform this transformation, we are going to dilate each coordinate, x and y, by 1/4. That means that we are going to multiply each coordinate by 1/4. So 1/4 times x and 1/4 times whatever the y coordinate is. And we're going to do this with each of our original coordinates. Then we are going to write our new coordinates with the prime notation. Okay, so we have the prime notation for A, B, C, D, and E. So we're going to take each coordinate and we're going to start by multiplying them by 1/4. So if we look at our original coordinates, we're going to take 0 and multiply 0 times 1/4 and 0 times 1/4. And anything times 0 is going to give me a 0. So my new coordinates for A would be 0, 0. So I'm going to come over here and I'm going to plot A prime at 0, 0. And I'm going to look at my coordinates for B. My coordinates for B are 3, 3. And I have to multiply each one of these by 1/4. Okay, so I don't know what 3 times 1/4 is, so I'm going to come over to the side and do 3 times 1/4. When I have a whole number that I'm multiplying by a fraction, I'm going to put a 1 underneath. And then I'm going to do 3 times 1, which is 3, and 1 times 4, which is 4. And that gives me 3/4. 3/4 is 0.75. Okay, when you graph this on a coordinate plane, you're going to graph it as 0.75. That means that when you're looking at your coordinate plane, you're going to look at the x-axis and you're not going to go all the way to 1. Okay, 0.75 is a little bit after 0.5, which is the same thing as 0.50. So you're going to look at your x-axis and you're going to go over a little bit, almost to 1, but you're going to go up another 0.75. So B prime should be right here, because B prime is 0.75 when you multiply by 1/4, and then 0.75. Now for our coordinates for C, you're going to do the same thing. We're going to multiply our coordinates 6 times 1/4 and 3 times 1/4. So I'm going to come down here and multiply 6 times 1/4. And since that's a whole number, I have to change it to a fraction, put a 1 underneath it. 1 times 6 is 6. 1 times 4 is 4. And then I have 6/4. I can't graph 6/4, so I'm going to reduce this by dividing it by a common number. So I can divide both of these by 2 to get 3/2. Okay, and I know that 3/2 is 1.5. So no longer is my coordinate 6 for x. When I multiply 6 times 1/4, I get 1.5. So the new coordinate for x for C would be 1.5. And then I've already multiplied the y coordinate, because up here I multiplied the y coordinate 3 times 1/4, and I got 0.75. So I'll do 0.75. There's no need to multiply it again if I already know what it is. So now I'm going to plot C prime. So I'm going to go over here to my graph and look at the x-axis, and I'm going to look a little bit past 1 because I'm looking at 1.5, and then I'm going to go up 0.75. So my coordinates should be about right here. So that would be C prime. So if you start to connect the figure, you can see that this figure is going to be smaller. Alright, if we're looking at D, when we multiply D by 1/4, we're going to do 1/4 times 6 and 1/4 times -3. We've already multiplied 1/4 times 6 to get 1.5. So D prime would be 1.5. And then the Y value for D is -3. We multiplied 3 times 1/4. So we know that 3 times 1/4 is 0.75. But this one is negative, because that was what the dy value was. So now we're going to plot D. To plot D, you go over on the x-axis to 1.5, but then instead of going up 0.75, you're going to go down because it's negative. So D prime should go right here. And notice again, whenever I'm plotting these, I'm putting the prime symbol so that you can tell what my original figure is and then what my new image is because of the prime symbol. So then when we go to transform E, we're going to take E, and it says that we're going to multiply it by 1/4. We are going to multiply each of those coordinates by 1/4. We've already done that. We've taken 3 and multiplied it by 1/4, and we got 0.75. So we do 0.75, and we're multiplying -3, so we know that this is going to be -0.75. And now I can plot E prime. So I'd go over here to my graph and look at the x value, and it's 0.75, so I'm going to go almost to 1, and then down almost to 1 to -0.75. That's going to be E prime. So now you can look at the figure and see that our scale factor was 1/4, and 1/4 actually is equal to 0.25. So in comparison with our original figure, our new figure is 1/4 the size of our larger figure. Okay, so it's smaller. Everything about these two figures is the same though. Okay, that's what makes them similar. They all have proportional ratios, and all of the angles are congruent.